A collision involving NASA's spacecraft could have resulted in a meteor shower that might persist for a century. Greetings to everyone. Today's video will focus on NASA's DART mission, which purposefully collided with the asteroid Dimorphos in 2022. This event may have resulted in a human-made meteor shower known as the Dimorphids, potentially lasting for a century. The collision released more than 2 million pounds of debris, with fragments anticipated to reach both Earth and Mars within the next 1 to 3 decades. Although the debris presents no threat to Earth, it has the potential to create visible meteors, especially in the southern hemisphere. The Hera mission will conduct future observations to delve deeper into the consequences of the impact and the behavior of the debris. Now let's dive into our discussion. Recent research suggests that the intentional impact of a NASA spacecraft on the asteroid Dimorphos in 2022 may have triggered a meteor shower that could last for a century. The debris released from Dimorphos following the collision with NASA's Double Asteroid Redirection Test, DART, spacecraft could result in the inaugural human-made meteor shower, aptly referred to as the Dimorphids. The DART mission was orchestrated by NASA to assess techniques for deflecting asteroids, which are essential for planetary defense. The aim was to find out if colliding a spacecraft with an asteroid traveling at 13,645 miles per hour, 6.1 kilometers per second, could effectively change its path. While neither Didymos, the larger parent asteroid, nor its moonlet Dimorphos presents a danger to Earth, Dimorphos was selected for this experiment because its size resembles that of potentially dangerous asteroids. For almost 2 years, astronomers have been observing the effects of the impact using ground-based telescopes, and they have verified that the DART mission successfully changed the movement of Dimorphos. The collision modified the orbital period of the moonlet asteroid, reducing the time it takes to orbit Didymos by around 32 to 33 minutes. Nevertheless, scientists estimate that the impact released more than 2 million pounds, almost 1 million kilograms of rocks and dust, sufficient to fill 6 or 7 rail cars. The final location of this debris in space is still unknown. Recent research indicates that pieces from Dimorphos could come close to Earth and Mars in the next 1 to 3 decades, with some fragments possibly reaching Mars in as little as 7 years. Additionally, smaller debris may penetrate Earth's atmosphere within the upcoming 10 years. This study has been approved for publication in the Planetary Science Journal. Eloy Peña Asensio, a postdoctoral researcher and the lead author of the study at Italy's Polytechnic University of Milan, indicated that these fragments have the potential to create visible meteors, often referred to as shooting stars, upon their entry into the Martian atmosphere. Once the initial particles arrive at Mars or Earth, they may continue to be visible intermittently for the next century, which aligns with the team's calculations. The size of these particles varies from grains of sand to pieces similar in size to smartphones, ensuring that they do not pose any danger to Earth. Peña Asensio emphasized that they would break apart in Earth's upper atmosphere due to ablation, a process driven by friction at hypervelocity. Establishing when this debris might arrive on Earth is a more intricate matter, relying on precise calculations of the fragment's speed. Prior to the impact during the DART mission, a small satellite called LISIACube was launched to record the collision and the debris cloud that followed. The footage captured has been essential for evaluating the debris produced by the impact. The research team utilized data from LISIACube, along with the supercomputing resources provided by the Consortium of University Services of Catalonia, to simulate the trajectories of 3 million particles created by the impact. Their modeling evaluated different possible pathways and speeds for these particles as they traveled through the solar system, while also taking into account the effects of solar radiation on their movement. Earlier forecasts indicated that debris from Dimorphos might potentially make its way to Earth or Mars, but this recent study concentrated on synchronizing simulations with the post-impact data obtained from LISIACube. The results of the study affirmed that if fragments were ejected from Dimorphos at velocities of 1,118 miles per hour, 500 meters per second, certain pieces could indeed reach Mars. Additionally, smaller debris traveling at speeds of 3,579 miles per hour, 1,600 meters per second, could possibly arrive at Earth. While there are some uncertainties regarding the debris, the researchers determined that the fastest particles could reach Earth in under a decade. Peña Asensio noted that although the chance of a Dimorphid's meteor shower taking place on Earth is improbable, it should not be completely ruled out. Should such an event occur, it would manifest as a faint meteor shower, easily distinguishable since it wouldn't align with any recognized meteor showers. This phenomenon would showcase slow-moving meteors, with peak activity expected in May, mainly observable from the southern hemisphere and seeming to emanate from the vicinity of the Indus constellation. The researchers speculated that debris from Dimorphos might have the potential to reach other nearby asteroids, though this possibility was not investigated in their study. Michael Kuppers, a planetary scientist at the European Space Astronomy Centre and co-author of the study, pointed out that while the impact was expected to generate debris, the possibility of that material reaching Earth or Mars could only be confirmed after the collision took place. Kuppers expressed his astonishment that, despite the impact occurring relatively close to Earth, approximately 11 million kilometers away, it appears easier for the debris to reach Mars than it is for it to reach Earth. This is likely due to Didymos crossing Mars' orbit, while remaining just outside that of Earth. Near-Earth asteroids like Phaethon can also expel particles, contributing to the Geminid meteor shower that occurs every December. Patrick Michel, an astrophysicist and research director at the National Centre for Scientific Research in France, who did not participate in the study, mentioned that analysing the material released by the DART impact could assist in predicting when similar debris may arrive at Earth or Mars. He recognised that although this study seeks to quantify this potential, it is based on models that inherently involve uncertainties. Peña Asensio indicated that future observations will play a crucial role in enhancing the measurements of the debris mass and velocity estimates, aiding in the prediction of possible meteor activity. The European Space Agency's Hera mission, set to launch in October and reach the asteroid system by late 2026, will conduct these observations. Hera, accompanied by 2 CubeSats, will investigate Dimorphos's composition, mass, and the consequences of the impact, including the extent of momentum transfer from the spacecraft to the asteroid. Kuppers, a project scientist for the Hera mission, posed fascinating inquiries regarding the consequences of the impact. Is there an impact crater, or was the force of the impact so great that Dimorphos underwent a global transformation? While ground-based observations indicate the latter scenario, Hera is set to deliver a conclusive response. Furthermore, the mission will determine if Dimorphos was left in a state of tumbling following the impact. In the end, Michel stated that this mission will provide astronomers with valuable information about the dynamic changes of debris created by an impact in such a complicated double asteroid system. To support our channel's growth and ensure broader awareness, kindly hit the like, share and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.